Nam owns a used car lot. He checked the odometers of the cars and recorded how far they had driven. He then created both a histogram and a box plot to display this same data. Both diagrams are shown below. Which display is more useful for approximating the minimum distance? Okay, so in the histogram, because we have buckets of data, we don't know the minimum, because the first group of cars, we see that from 0 to 50 we have 3 cars, but we don't know the exact value of the minimum value. Okay, it could be 0, it could be 10, it could be 20. We don't know exactly the minimum value of this group here. We know that there are 3 cars that drove between 0 and 50, but we don't know the exact minimum value. Opposed to the box plot, where we see exactly the minimum value with 1,000 kilometers. So for the first question, the box plot is definitely more useful. As for the second question, which display can be used to find that there were 23 vehicles at Nam's used car lot? Okay, so here the histogram tells us exactly how many cars are represented in this display, because we can add them up. We have 3 cars that drove between 0 and 50, 4 cars between 50 and 1,000, 100, and so on. So we have 3 and 4 is 7, 7 and 5 is 12, 12 and 6 is 18, 6 and 3, 18 and 3 is 21, and we have another 2 here, so 21 and 2 is 23 in total. So we know here there are 23 cars that are represented in this display. As for the box plot, we don't know how many data points we have here. We know that there are 25% of the data represented in the first quartile, 25% in the second quartile, but we don't, and so on. This is the third quartile, and this is the fourth quartile, but we don't know how many data points we have in each of the quartiles. So the box plot is not good for finding out exactly how many data points are represented in the display, in the graph. So as for the second question, the histogram is the graph that is useful to answer that question. So let's see if this is correct. So the first question is which display is more useful for approximating the minimum distance. So this is the box plot, as we saw here. We know exactly the minimum value, and which display can be used to find that there were 23 vehicles. So this is the histogram, and as for the box plot, we don't know how many data points are represented. So let's move on to the next question. Regina is a realtor and studies house prices. She recorded the area of each house on Prince Street. She then created 2 histograms to display the data. Histogram A shows the data using a bin width of 50, and histogram B shows the same data using a bin width of 100. Both diagrams are shown below. So let's have a look at the diagrams, and let me copy them to the board. So this is histogram A. And this is histogram B. I'm copying it to the board so it will be more comfortable looking at them both at the same time. so I don't have to scroll all the time. Which histogram can be used to find, I'll copy the question as well. Which histogram can be used to find how many houses and areas had areas less than 150 square meters? Okay. Okay, so obviously histogram A, because the brackets of histogram A have a size of 50. So here we can tell that there are 7 houses. Has an area. I have an area of 100 to 150, and 4 have an area of 50 to 100. So in total we have 7 plus 4, we have 11 houses that have an area less than 150 square meters. Okay, whereas in histogram B, okay, we have a bucket here with a size of 100, so we don't know how many houses fall in the 150 square portion of this group. Okay, so this group represents all the houses that have an area of 100 to 200, but we don't know how many houses have an area of 150 or less. So this question, histogram A, is the one that can give us the answer. Which histogram can be used to find how many houses had areas less than 150 square meters? Histogram A. Histogram A only. Okay. Only one question here. Yeah. Histogram A, histogram B. Which histogram can be used to find how many houses had less than? Okay. Tia measured the daily high temperature in Katz, Colorado for each of the 30 days in April. She then created both dot plot and the box plot to display the same data, both diagrams shown below. So let me first copy the displays, the graphs. So this is the dot plot. And this is the box plot. Okay, and the question is, which display can be used to find how many days had a high temperature above 15 degrees Celsius? Above how many, so the dot plot tells us exactly how many data points we have above 15 degrees Celsius, but here this is the 15 degrees Celsius mark. We don't know how many data points we have here. This is the 4th quartile. We know that 25% of the data points are in this quartile, but we don't know how many data points there are, and of course we don't know how many data points are in this section. So obviously for this question the dot plot is more useful. So which display can be used to find how many days had a high temperature above 15 degrees Celsius? So this is the dot plot. Which display makes it easier? I'll copy this question to the board. Which display can be used to find how many days had a high temperature above 15%, 15 degrees, 15%, 15 degrees Celsius? How many days had a high temperature above 15? I'm sorry. I answered the... okay, so I mixed up. Sorry. So this question, which display can be used, how many days had a high temperature above 15 degrees Celsius? This question, the answer to this question is the dot plot, because we saw that we cannot tell how many days from the box plot, because the box plot does not tell us how many data points we have above 15 degrees Celsius. The dot plot does tell us this information. The second question, which display makes it easier to see that the first quartile is 9. The first quartile is 9. Okay, so this is obviously the box plot and makes it easier. Okay, so we can also deduce it from the dot plot because we have all the data points and we can arrange them and calculate the first quartile, but in the box plot it's already given to us that the first quartile is 9 degrees Celsius, and in the dot plot it will be much harder to deduce it from the dot plot because we will have to arrange all the data points and count them and divide them to quartiles, so the box plot is a lot easier in this respect. Okay, so which display makes it easier to say that the first quartile is 9 degrees Celsius? The box plot, sorry. Okay. Next question is, Leonard measured the mass of each pumpkin in his patch to the nearest tenth of a kilogram. He then created both a histogram and a box plot to display the same data. Both diagrams are shown below. Okay, so let me copy the histogram to the board. This is the histogram. And then the box plot. Now, okay, so first question is, which display can be used to find the maximum mass? Okay, so here the answer is obvious because the box plot tells us exactly the maximum mass, but the histogram has a bucket of 12 to 14.9, so we don't know exactly the value of the heaviest pumpkin. We know that the heaviest pumpkin is in this group, but we have two pumpkins between 12 and 14.9, but we don't know the exact value of the heaviest pumpkin, whereas in the box plot we know that the heaviest pumpkin is 14. So for answer 1, for question 1, the answer is the box plot. And now question 2. Which display can be used to find that there were 25 pumpkins in Leonard's patch? Okay, so the box plot is not good for this because the box plot does not tell us how many data points are represented in the graph, whereas the histogram, we can tally the number of pumpkins of each bar. So we have 4 pumpkins in this range and 5 pumpkins in this range, and another 8 here, and 6 pumpkins here, and another 2 pumpkins here. So we have a total of 4 plus 5 is 9, 9 plus 8 is 17, 17 plus 6 is 23, 23 plus 2. So we have a total of 25 pumpkins that are represented in this histogram, but in the box plot we cannot tell how many data points we have represented, so the histogram is the more useful for this question. Which display can be used to find that there were 25 pumpkins? The histogram. Good. Awesome. So in the next video, I will move on to this section, shape of data distributions, and I will do these practices. So I will see you in the next video.